Okay, so we have this next question right here. It says a small spherical air bubble moves upwards in a glass of water, and the drag force on the bubble can be calculated using Stokes' law. State the condition needed for Stokes' law to apply to the bubble. So let's write the condition. The first condition is that it should be small. The second condition, it should be spherical. The third condition, it should be laminar flow, not turbulent, laminar flow, or you can say not turbulent, not turbulent. And the fourth one is relatively low velocity. Okay, these are the four conditions. Main are like the mains ones are the first, second, and third. Fourth one is an additional condition. So let's see which of these have been given to us. They have told us that it is small, it is spherical, and it is moving upwards. So it's the best thing to write the third point. You can also write the fourth point for safety, but when it's like for 1 marks, just write the main ones like first, second, and third. So you can just write the flow should be laminar, and you can also add another point for safety that and it should have relatively low velocity. Okay, simple as that. So let's go to the next part. Okay, so we have this next part here. It says the bubble moves upwards at a constant velocity. The volume of the bubble is 5.3 times 10 raised to power minus 11 meter cube. Show that the upthrust on the bubble is about 5 times 10 raised to power minus 7 newtons, and the density of water is 998 kg meter per meter cube. Okay, so our first step, let's do it step by step. Our first step is to identify what values we have been given. So we have volume, we have density, and we need to find the upthrust. Okay, so what is the formula of upthrust? Upthrust is equal to the weight of the displaced liquid fluid. Okay, and the formula will be mg. Upthrust is equals to mg, but this mass is basically the mass of the displaced liquid. Okay, now we will use the densities formula, which is density is equals to mass by volume, and make it mass equals to dv, and then you are left with, instead of d, just use the symbol which is something like p. So use this density symbol v and g. Now if you input the values, we have density as 998 times, you have volume, which is 5.3 times 10 raised to power minus 11, and you have gravity, which is 9.81, and if you multiply this, your answer will be 5.19 times 10 raised to power minus 7 rounded off, and you will get 5.2 times 10 raised to power minus 7. Hence we have proved our answer. Okay, so we have this next part right here. It says the bubble moves upwards at a constant velocity of 0.035 meter per second. Deduce whether the Stokes law applies to the bubble. You may ignore the weight of the bubble. Viscosity of the water is 9.5 times 10 raised to power minus 4 Pascal second. So I have written some values from the previous part, which was, one is upthrust and the other one is volume. Okay, and I have to discuss one more thing with you guys, which is the constant velocity. Constant velocity means net force, right? Net force equals to 0, right? In other words, constant velocity is that it reached the terminal velocity. Okay, now let's draw this. Basically the thing I have just said, net force is equals to 0. So how will it look like in a drawing? Okay, so we have this bubble here, and if we had weight would have been acting downwards, but they ask us to ignore it. So now we have up thrust at upside, right, and it is moving up, so the drag force will be opposite to the direction of motion where it's moving, right? So if it's moving upwards, drag force will be opposite to it. So drag force is downwards. Now net force equals to 0 means that your up thrust is equal to drag force, right? So if it is equal to drag force, we are going to check it using our calculation. If they are equal, then it means that the Stokes laws is applied here. Otherwise, it is not being applied here. So let's calculate the drag force. So we have drag force formula, which is 6 is equals to, sorry, not 6, my bad. It's F is equals to 6 pi r viscosity and V. So we have viscosity value and we have constant velocity, or in other words terminal velocity value 0.035. We don't have radius, so to get radius we can use our volume formula, volume of sphere, because the bubble is a small spherical stuff. So volume of sphere, right, is equals to 4 by 3 pi r cube. We have volume, which is 5.3 times 10 raised to power minus 11, and then you have everything value and you need to find the radius. Okay, so 4 by 3 pi radius r cube. Okay, now if you just shift 4 by 3 and pi over there, it will look like this, which is 5.3 times 10 raised to power minus 11 times 3 by 4 pi, and if you shift this cube to the other side, it will be cube root, and if you solve it, right, cube root of all of this value, you will get your answer as 2.33 times 10 to the power minus 4 meter. Okay, so now you will use this radius here in the drag force formula. So F is equals to 6 pi, your radius is 2.33 times 10 to the power minus 4. Okay, and your viscosity is 9.5 times 10 raised to power minus 4 Pascal seconds, and you have constant velocity or terminal velocity as 0.035 meter per second. If you calculate the force value, you will get as 1.46 times 10 raised to power minus 7 newtons, right? Now if we compare this value with the upthrust value, you can see that they are not actually equal. They're like far away, right? So you can just simply say that 1.46 times 10 raised to power minus 7 Newton is not equal to sign, and just say 5.3 times 10 raised to power minus 11. So it doesn't follow, or the Stokes law doesn't apply, right? Doesn't follow the Stokes law. Okay. So yeah, this is your final answer.